Alright, so second video is going to deal with esters and acids. So let's just give a general overview of what an ester is and what an acid is. If you what's common to both of these functional groups is what's called a carbonyl group or a C double bond O group. So that's a C. Again, you remember this from earlier. A double bond is just a pi bond and a sigma bond. So there's a pi bond and a sigma bond between carbon and oxygen. Right. On the left side, this is an acid, a carboxylic acid. You'll see this functional group in biology 230 and 250. Dr. Griffin is going to ask you about this functional group, wherever your professor may be. And again, it's a carbonyl here, C double bond O, with an OH attached to it. Right? These three atoms, C double bond O, OH, make this particular functional group a carboxylic acid. Okay? Over here we have an ester. Right? Notice the difference. Here you have your carbonyl, that's common to both C double bond O, but here instead of an OH you have an OCH3, and this is generally any type of alkyl group. Remember that from the first slide. Any carbon containing group, carbon chain, it can be one carbon or 10 carbons. If it's all carbons, then it's alkyl, and if those carbons are connected to an oxygen, like here, it becomes an alkoxy group. Al meaning alkyl and oxy meaning oxygen. Alright, so let me just circle that. So here's the al part for the alkane, the CH3. This can be one carbon or it can be multiple carbons. And then the oxy, meaning that those carbons are bound to an oxygen. Alright. And so here's some ester derivatives. Carbonates, notice you have a C double bond O and you have an OR or an alkoxy group on either side of the carbonyl. We call that a carbonate, where R is just in organic chemistry. You're going to see R a lot. R is just a generic descriptor, right? It can be any group, but in this case for the carbonate, R is going to be some alkyl group. All right. Also, in hydrides or ester derivatives, notice the oxygen is here and there's a carbonyl bound to either side of it. Okay, you're going to see this compound when you take organic 1 lab and you have to make aspirin. This compound here is acetic anhydride. Alright, so knowing this, let's look at some practical applications and look at some places where we can find some esters and some acids. Again, if you look at this compound here, this is heroin. This is at the actual structure of the drug heroin. You know, it's derived from the opium poppy, and first processed in 1874 and then resynthesized 23 years later, 1897, by Felix Hoffman while he was working for Bayer. And this is the same chemist, Felix Hoffman, that synthesized aspirin. And so what many people don't know is that in the brain, heroin gets metabolized into morphine, and morphine is what binds to the opioid receptors in the brain. Okay, so heroin has an ester, right? This is C double bond O, this is O, and then over here, right, that's the carbon group. So this is the alkoxy part here, and then this is the carbonyl here. So C double bond O, right, O, C. It didn't say what the C had to be. It doesn't have to be CH3, right? It just has to be a carbon. All right, so this is an ester. All right. Okay. And so let's make this really plain. So let's look at heroin. This is heroin, right? This is the structure for heroin. This is codeine. I remember listening to Lil Wayne say something about, you know, don't worry about what's in my cup. It could be heroin in my cup. Well, I don't think he really understands that codeine and heroin are basically cousins, right? Look at the difference. This is the only difference here, right? These these ester groups out here on heroin, and then over here you have a free OH group and then an OCH3 group. That's the only difference between those compounds. So while he's putting Twister or Sprite or Jolly Ranchers or whatever into his cup, he's actually codeine is very close in structure to heroin. So that's really important to remember. Alright, just make it look a little bit practical. So this is vitamin C, right? It can be synthesized from ascorbic acid by an enzyme to give you L-ascorbate. This is the vitamin C that the body actually absorbs. In the book Napoleon's Buttons, one of the things that the book talks about is James Smith, who was a captain of a ship, and he's credited with discovering much of the southern hemisphere because he figured out a way to grow citrus plants on his ships, and his sailors didn't die of scurvy, so they were able to sail for long periods of time and not become vitamin C deficient. Right? So if you look at vitamin C, again, this is an ester. This is the C double bond O right here, right? And then if you go here, this is the O, and then this is the carbon attached to that O. So this is your alkoxy group here. So C double bond O, O carbon, right? That's an ester. Right? Down here in ascorbic acid, this is a carboxylic acid. Remember, C double bond O, OH, right? C double bond O, OH. That's an acid, right? So up here you have C double bond O, OC. This is C double bond O, OH. Right? Ibuprofen is another compound that contains a carboxylic acid. You can see it again, C double bond O, OH. This is the same ibuprofen that you take for a headache or muscle aches or back aches. So let's see if I can get the pen to work, and let's see if we can draw an ester. Right, so let's draw an ester. So C double bond O, right? O, let's just say CH3. And then over here, let's just put a carbon chain, 5 carbons, right? And then let's write in the CH3 at the end. All right. What about an acid? Remember, the acid is different, right? It's OH, C double bond O, and then let's just put that same carbon chain out here. So you can practice these on your own, and I think you'll get the hang of it if you put the work in. Right? So the next video we're going to talk about aldehydes and ketones. We're going to just add it to this video. These are very simple compounds to understand. If you notice here, again, it's a carbonyl, has a carbonyl base, right? The functional group here is the carbonyl. Same for the ketone here. And if you notice, the difference is here, the aldehyde has a hydrogen attached to that carbonyl right here, and then over here with the ketone, it's a carbonyl with carbon on either side. So here and also here. Right, very simple. Right, the simplest aldehyde or the simplest ketone is acetone. This is used for fingernail polish remover. Same stuff they use in the salon, the same stuff that's in your dorm room if you polish your nails and you want to take the nail polish off. All right. The simplest aldehyde is formaldehyde, which is shown here. It's used in embalming fluid. It's also found in cigarette smoke, so that's a PSA to not smoke. All right, so let's draw an aldehyde. Let's draw one really simple. So you know the base of that compound is the carbonyl, C double bond O, and then let's just put an H here, and let's draw a nice little chain out here, CH3. Right, that's an aldehyde, and let's draw a ketone. So let's start with CH3, and then C double bond O, and then CH3. All right. So you can practice ketones and aldehydes, and also esters and acids, and you get some time. And I'm going to stop this video, and then we'll move on to the next video.